Yeah, so good morning, everybody. Paolo here. We continue the SWAT session, starting from where we stopped yesterday. Maybe Giacomo, now you can make a little bit of a recap, step by step, through what you have gone through yesterday. Yesterday there was a little bit of an interaction with the trainees. That's definitely more than welcome, because so we can understand if you have issues or you're able to follow up. So please interrupt us whenever, no problem. Let's try to make this thing to be as fruitful as possible, considering the limitations of the virtual trainings. At any rate, let's go through a little bit through the steps Giacomo went through yesterday, and then so that then we can continue. Okay, Giacomo, I'll leave the floor to you. Or if there is any question now before we start, please feel free to put question now.
Okay, thank you for being here for the second day of SWAT training. Okay, first of all, before doing some recap of what we did yesterday, if you remember, I said that for the installation and the correct working of some of the SWAT components, we would need to disable some antivirus, protection of the antivirus. Otherwise, especially the SWAT editor will not be installed, and it will not work. So in my case, I will disable my antivirus before the starting. You should do the same. The protection. Okay, in the meantime, we can open our QGIS project. I will open QGIS. As I told you, we will need to have a version of 3.34 or some later versions that can accept the plugin of SWAT. So I will open mine. I was working with the demo one project. You should have created a one called demo. If you have it, please open. Okay, going to second to the presentation. Yesterday we have seen we gave a look to this component of QSWAT. We have saw like an overview of the program, how to set up the SWAT software, and we have been into the watershed delineation. That now we will be go back a little to this point about the loading of the dam, of the creation of a channel and streams, and the creation of landscape units with the floodplain and the upslope division of our watershed. And then we have seen about the hydrological response unit definition that takes into account also the land use and the soil maps that are given to the program. And then after this today, we will see, again, we will finish about the hydrological response unit definition, and we will see in detail what is it in a SWAT editor, especially about the weather data, the insertion of weather data, the setting of a simulation period, and how to set our print options for the simulation. And then there is a final part that deals with the output visualization of our inputs and outputs, or in general of the result of the SWAT simulation. That can be static simulation. We can have some animation or some plot, some different type of plots. But so about yesterday, I will do a little recap of the steps we have done yesterday for the watershed creation. So as yesterday, we will have always to open the plugin of QSWAT Plus. And here we have the principal window that make us to complete our steps for the SWAT simulation. The first step we've done is before of course we created the project, we selected the folder to our project. And then the first part was the delineation of the watershed. That is this first step here, where we added this window where we could set some parameters. The first one, of course, was the selection of the dam. So we had selected the dam. In this case, we had a file, a TIFF file in our folder, in the example datasets folder of our SWAT, of the Rabbit SWAT. There was this dam folder with this SRTM. And if you remember, we have uploaded this file here, the hdr.adf, that when we uploaded, it is converted automatically by the program in this TIFF file, SRTM underscore in 30 meters resolution TIFF files. Then the second step was for delineation of the watershed in this tab, was the use of a burn-in existing stream network. That means that we had already a stream that was coming from other models or from or maybe made by yourself in some other program or in some other way. And there is the possibility to upload this already existing network so that the SWAT program will base its calculation and its delineation of its streams and watershed based on this actual representation of flow. So we had selected also here that we had in the folder these aerobic streams, and we had already this aerobrich.shape file, the shape file to use for the burn-in of the stream network. Then we had to select the threshold for the creation of our streams. Here we could select both, we could write both in the cell number in this cell space or with the area, and we decided to write our number here in the area. Actually, we had selected the hectares here in the unit, and then the number we was written here was okay. Actually, here I should have it here in the presentation. The number we typed to do our exercise was exactly 9 for the area in hectares, and 90 for the areas. Okay, here 9. Here it is for the area in hectares for channels, and for what concerned the streams, 90 hectares area. Then we had to upload a main outlet. That is the final outlet of the basin. That is, in this case, we had selected the outlet from the folder here again in the Robin subfolder main outlet. There was this shape file already here that we had selected before. So we had opened it, and as you see here from the map, this is the location of our outlet, final outlet. And you could also add drone. There was the possibility, as we have seen yesterday, as we tried some drawing of outlet, to draw by hand in different part of the basin some outlet or inlet in case we have some data of flow in any part of the basin. We can draw some inlet, and then there was this option to set a threshold snap, so that if you draw a point that is next to a river, maybe if I draw a point here, but not specifically into the river, that is what is asked by SWAT, it will be automatically snapped. That is that the point will be moved exactly on the river. That is what we need. Okay, and this was about and then we had to press to click on the buttons create the streams at first to create the streams, and then to create watershed here to create the watershed. And this was the result. Let me remove these files that were created after. This was the result of the delineation of the watershed with the streams, or let's say the channels, the one in light blue, and the reaches that are the one in dark blue. And at the end also we have the creation of this sub basin with this configuration that is given by the different values we have put here on the area, on the channel and stream threshold for the area. Then the next step that we did was the creation of the landscape in this tab here. And this creation of the landscape, if you remember, was about the definition of some buffer that is around our channels, because we consider SWAT considers in a different way for its simulation if we are in a floodplain or if we are in an upslope area. So we had created this. We tried with these three methods. That was buffer channels, dam inversion, branch length. We kept the values here as default as they are done. So we had created these other three files that were these floodplains by branch here, this floodplain by inversion, and this floodplain by buffer. Okay, here in this case, we are not seeing the floodplains, but just because we are at a step further. So it is already included in the next step, in the next calculation for the landscape unit calculation. But we use these three, and we calculated these three, and at the end, for the final calculation of the SWAT model, we will need to use just one of these. Okay, let me put this back. Okay, the next step we have tried was this option of merge subbasins, where we could actually merge some basin that with the possibility of select some basin to merge. We have tried, for example, to merge these two basins. In this case, we don't want actually to merge it, but there is this option that for your purpose, if you need it, if you have some very small basin, it's useful. And so you know that there is this option. Now I cancel, I don't do the merge. And then there was also the option of adding lakes that for our exercise, we actually did not have. So we skipped this part, but there was the possibility of add some shapefile of a lake in case you have it. So this was the first step of the SWAT model, the delineation of the watershed. I close the tab. Then the second step was the creation of HRU, that is the hydrological response unit. That means that is the unit for which the SWAT model is doing the calculation for its simulation. So if the watershed has some different characteristics, the SWAT model will calculate it in a different way. And specifically, which is this difference? It will calculate the difference, as we said before, for the landscape unit among the upslope and the floodplain. This was one difference between different terrains. But the other big step is when we put as an input the land use and the soil, that will, with their own and different characteristic, that they will change the way how the model will work. So if we go here to this create HRUs, okay, there was this tab about land use and soil, where we had to select at first here the land use map that we had in our folder. Again, in the Robit folder of the exercise, we have the land use in the folder land use here. And we had to put, as before, as the DEM, the hdr.adf. And that's what we have done. Again, the same thing for the soil, for the selection of the soil map. That is done here again from the folder, in this case called soil, where we added this soil and at 90 meter resolution. Again, we had uploaded this hdr.adf. And then if you remember, as you see from the name here, soil 90 clip.tif, it means that the program has already clipped the file respect to our basin. So because probably the original file, the original soil file, is bigger as an area that cover a much bigger area than our watershed. And the SWAT program will clip this soil file according to what is the needed for the model. So just for the area that's around our watershed. Then the other steps to look at is this, for the soil data, we had to check the user soil option, because the other two options, StatsGo and Surgo, they contain soil information, but only for the USA soil. So in this case, for the worldwide soil, we will use this user soil. And again, what we need for the model is the creation of our lookup table, that are the description of what is in the land use and soil maps. So we had some tables that were already created, that for us were for the land use lookup. Actually, our lookup table, we had to select the CSV file, and we had if I go back here, in the folder to select, we had this robit._landuses.csv, that is the lookup table that we need. So I click on it, and the same thing for the soil lookup. For the soil lookup, So here we have selected the CSV file that is called, in this case, robit_soils.csv. I will click on it, but I have already in my list. That is this robit soils. And in this case, actually, I can select the one I did before. In this case, it changed the name because I selected it many times. So it's adding actually some numbers. What is the Robin land uses? That's the final one. For the user soil, for this line here, we had selected also for the use CSV file. There is this robit_user soil file that we selected. Robit_user soil, this one. For the planter urban, we keep the option that's written here, plant urban. This is about the selection of the floodplain that we had created. There were these 3 different floodplains that we have created, the one with different options by branch, by inversion, or by buffer. And we decided to select the one by inversion. That is called invflood0_10.tif. So we selected from the list. Then some other things that we have added are here in the select slope bands, where we could divide our watershed in different slope bands. At the beginning, the option was between 0 and infinite and 9999, but we wanted to put the difference between the slopes that were lower than 10% and the slopes that were higher than 10%. So we added the number here, the 10 here, and we had inserted with this button the new slope band, so that we have at the end this 0, 10, and 9999. So this was for the slope band. The other option to work with was this short channel merge that led to reduce the calculation of for some watershed, removing or better merging the very small channels into the closest one. In this case, we had chosen the option percent in a percent of a subbasin with the number 2. So the channels that has a less than 2% percentage respect of the subbasin is merged to the bigger one closest to close to them. Then the other thing to select was this generate the full HR shape file that allow us to see to have a shape file that is created of the HRU that are the hydrological response unit, and allow us to make the actual calculation and at the end the visualization of the output. So it has to be ticked. And from here then we have to tick the option of the read choice of read from maps, or in case that you created before this option and you leave the same thing as before, you can just read from previous, so that it takes the same option of before. In this case, I change just a name here in the tables, so I will have to read again from maps. So I will go on read from maps. So it is going to create the new HRU file. It's doing some calculations, so it can take some time. It depends on your laptop, basically. It's still calculating. Okay, let me see if it's working. Okay, maybe in this case, we will have some error because it's going on the calculation, but it will not show the result. In my case, actually, I can go back. Let me see if I can close this window, since I already created yesterday the files. I might go back again to step 2, create watershed. Okay, now that I have the options set of yesterday, I can go back to the read from previews that you should have the option available in order to redo the calculation that we did yesterday, because you have to do it again, otherwise we cannot click the next step of the process, that is this HRU tab here on the top. So if I go here on read from previews, and I go to read, okay, now it worked. We actually have the sub-basin count 9, the channel count that was 72, and the full HRUs count that is 461. Okay, at this point we can actually go to the next step of the process, because we are able to click on these HRUs. Okay, let me go to the part of the presentation where we have arrived. Okay, before I have to check one thing, because as you see, there is in this part of the in this tab of HRUs where we should select our options. I am not able to click on the settings because everything is gray. So I will try again in the land use and soil tab to read again to redo this read choice. I will try to read. Okay, and now as you see in this HRU tab, we are able to click and modify the option we need. So sometimes there are some yeah, let's say some issues in this software, just to as you know, sometimes it's not possible to click on some option. So you will have specifically at this part to read again the choice, press again the read to obtain, as I'm doing now, the available option for the HRU selection. So also. Let me move a little bit the screen. Okay, we'll increase. Second. Okay. Okay, we arrived to this part of the preparation for the creation of hydrological response unit. These are the hydrological response unit we had created yesterday, the green one here. Now I can remove the other layers so you can see them. remove the floodplains. This one in green were the hydrological response unit of yesterday. And starting from that, there is the possibility to create the actual HRUs, the final HRUs that are actually used in the project. That is a selection of the full HRUs. Indeed, this one, as you see, are called full HRUs, and we will create some, we will obtain a lower number of HRUs to do a better calculation according to some parameters. So some things to modify about these HRUs is the splitting. Okay, I go here to the tab. This first part as optional. These split land uses and exempt land uses that are two further options now available in this form. So what are doing this option? These split land uses that open this tab here allow us to divide existing land uses. We suppose, for example, that we know that 50% of the agricultural area in our land use, agricultural, that is generic agriculture, we know what is cultivated inside this specific area. So, for example, we have 50% of corn and 50% of teff. How can we do this? We first select the agriculture area here in the select land use to split. Here are the 3 land use that we can choose, that are in the watershed. So we select the AGRL, agriculture. And now we have this select sub land use tab. So we have this pull down menu from where we have to select the corn. Corn is the first one let me find it. Okay, it's here. We know that 50% of the area is corn, so we select it. We press OK. So now it appeared here in this table here. It completes this first line of the table. And then we will modify this percent. At first, I can also click this add sub land use to add the other agriculture that we know that is done in this area. That is the teff. So we will look for the teff. Down. Okay, see here, teff grass. I click on it, select OK. So now what we still have to modify is the percent, because we know that is 50-50. So we write here 50 for the corn, and again 50 for the teff. So actually now we are okay with this representation, and as we see, agriculture is divided into corn and teff. We click then on Save Edits here, Save Edits, and then to Save Splits. Okay, now we are go back to our initial tab. What we want to modify then is this optional exempt land use. That means that marking some land with this, they will not be removed when we come later to remove the small HRU, because the next step will be the removal of the very small HRU. But if we select from this tab some exemption, for example, in this case, we would like that the forest will be maintained in our land use, even if there are very small pixels, let's say, of this. But if I wanted to take them, to keep them in for the calculation, even if they are small, I click on this FRST, that is the forest. And then, okay, it appears here in the example land uses. And I click on OK. Now we have done this optional part. So the next step, that is the this creation of HRUs. Because if I go to the presentation, yes, subdividing the watershed into areas with a unique land use, soils and slope, as we have done before, enables the model to reflect these differences in the evapotranspiration, specifically for the various crops and the soils. Because the runoff is predicted separately for each HRUs and is routed to obtain the total runoff for the watershed. So this division in different small areas increases the accuracy and gives a much better physical description of the water balance. And this step that we are doing is the one to select a choice to describe our new HRUs. The first difference between these 5 choices that are, I read them, they are dominant land use soil slope, dominant HRU, filter by land use soil slope, filter by area, target number of HRUs. The first 2 are actually called single HRUs selection, and the second part, the second 3, the last 3 are some multiple HRUs selection. And I will show you now what does it mean. Okay, these first 2 choices. Let's say the first one, this dominant land use soil and slope. How does it calculate the final HRU that we will use in the model? It actually chooses the land use with the biggest area in our landscape unit, in each of the landscape unit. Then he finds the soil that has the biggest area in the landscape unit, and then the slope range that has the biggest area in each of the landscape unit. And they use this combination of land use, soil, and slope for the creation of a new landscape unit with these characteristics. So we will not have actually all of these small pixels for the HRUs, but they will be the landscape unit that are the one in pink that I show you now, that they are bigger, the one created before, and they will have the characteristics of land use, soil, and slope that are the most important of each area, the most larger, let's say, of the area. And this was one option. So we can try actually to obtain this one, to do the calculation with this one, and we see which is the result in our map. So I select this dominant land use soil. Here I keep this groundwater uses SWAT plus aquifers. I click on create HRUs. Okay, now we see here in the map what's happening. Later we talk you about this point that have been created. But as we see, there is this, because before we had the full HRU layer here in green, the one selected with all the HRUs possible. And now it has been created these actual HRUs that actually visually is not very intuitive to understand what's happening, because it's giving the characteristics of the HRUs we are seeing now, only of the green one, to all the, let's say in this case, this area in pink, to all the landscape unit that that is described among each subbasin. So even actually if we see these voids, it's just because this is not in this white space, just because its soil or land use or slope characteristic is not included in the model, but this part will take the same characteristic as the one that are in the other part, in the other area. And this was the first of the choices for the HRU creation. If I click then, I go back for the create HRUs. Again, I have to go to this tab, land use and soil, read from previous. I go on read. Again, HRU. There is this second one, dominant HRU. And this option here selected the largest of the potential HRUs in each landscape unit. And make its land use, soil and slope range the ones chosen for the whole landscape unit. So it's quite similar. It has a similar operation of the one above, but it will give a little bit different result. So if I try here to create the HRU, you see from the result is quite similar to this new layer to the one obtained before. But this was just to have an idea of that we have this option, because at the end we will not choose one of these. We will choose. I will show you later. So I go back to land use, soil, read. We can now open HRUs. So next options are these three choices that are multiple choices. And if one of these are chosen, it is possible to reduce the number of hydrological response units by eliminating small ones and redistributing their area proportionally amongst the larger one. So, for example, the first one, this filter by land use, soil and slope, will ignore any potential HRU for which the land use, soil or slope is less than a selected threshold. The areas of HRUs that are ignored will be distributed proportionally among those that are retained with the landscape unit. Similar, the filter by area that will ignore just HRUs that are below a specific threshold amount. So considering the area of the HRU, so it will, let's say, eliminate the just small area or the small pixels. And the third one, the target numbers of HRU, will limit the number of HRUs in the whole watershed to use a preferred amount. So we can select a number to say we want just, I don't know, 100 HRUs instead of the 500 that we already had. So we can modify this number. Okay, the one that we will see now is this filter by area. That, as I said, is a choice of threshold method, where we can decide a threshold value. So in this method, we can select among this percent of a landscape unit or area in hectare. If we select the percent of area unit and we select the value, for example, here, like 10, we can write a 10. It means that HRUs which are less than 10% of their landscape unit will be removed. So some HRUs will be removed in a way similar to this one that we see from the map, removing some HRUs and then redistributing the the values of the one that remains. A similar thing is with the area instead of the percent of landscape unit, but the procedure is like the same. So if we select 5 years, here we see here that there are 76 is the number of hectares of our watershed, and we know that if we select 5, so all the areas with all the hydrological response unit with area less than 5 will be removed. So this is about the filter by area. The other option is setting by target. So this one, target number of HRU. Also here we can select between a percent of landscape unit and area by hectare. For example, let's say, suppose that we want a target of 250 HRU that we can write here. And we select this percent of landscape unit, then the HRUs will be sorted in order of their percentages of landscape unit. And in this case, the smallest, the remaining part, that is 211, in this case, they will be removed. The same thing for the area, is just that is taken into account for the sorting their area in hectares instead of the percent of landscape unit, but the process is quite similar. So in general, targets are typically exceeded when exemptions for some land uses have been chosen. So if you remember, before we have chosen the exemptions of forest. So what's happening is that even if there is an area that's smaller of a certain number, and it is a forest that we have selected before, it will not be removed in this case, but it will be kept. So probably we still have a number of HRUs that higher than this, because some of them actually cannot be removed. So we can play with the numbers to see what's happening to our result and to see what we will need at the end. Okay, the other option that will be the one that we will be actually use for this exercise is the filter by land use, soil, and slope. So after we select this, we see that there are these options here that we don't clearly read the what's written, but I have it from the presentation, the screenshot, because the words are not well displayed. Actually, it happens sometimes depending on the resolution of your laptop and the size of the character you are setting. But the first tab is about the possibility to set a land use percentage. The second one is percentage or area, because also here we can select percent of landscape or area. And again, for the soil and for the slope. So what we want to do for our exercise is to set percent of landscape unit here. And for the land use, we want to write 10 here. As you see, this 51 that is proposing here indicates that this is the lowest percentage for a dominant land use across the landscape unit. So you cannot choose values that are higher of 51, because that is, let's say, the maximum. So we want, for example, I decided to give 10 to this value, and I then click OK. So I can go to this soil option to select. And we again want to write 10 as the number respect to the 51 that is the maximum available. I click on go. And the same thing for the slope. We have a maximum of 50, but we decide to just keep to give 10 as this number. Okay, at this point I can go to for the creation of the HRUs that are the one that we will use for the next part of the exercise. Okay, at this point that we have this new hydrological response unit. Okay, as you saw before, there was the groundwater option. I show you again the land use soil, read HRUs, there is down this groundwater option that enables user to use, there is a groundwater flow module, but for this exercise, we can keep the default option that is this SWAT plus aquifer. So we don't need other files, and we just use the default option that are inside the program for the groundwater. Okay, now in this in the main tab of the QSWAT here, we see under this report selection. There is a new report available that is the HRUs, this last one. I can open it to show you what is showing. This gives a detailed actual and it's a detail about the for each watershed and each basin. For each it gives land use, soil, and slope data for each of the created hydrological response unit. So, for example, here, or better, for each of the basin that we have in our model. For example, here if you go in subbasin 1, we will have the final division of land use with the final option. So we will have, if I go, there is for percentage, in this case, 81% is the, if I look at this column, the agriculture that is divided as we selected before in 41 here of corn and 41 of teff. So we check that it has been taken into account the new selection we have made before, and then 11 for pasture and 5 for forest. So we see that even if this forest is small, I don't know if this case is quite small, but it is taken into account in any case, even if we have a very small, very small pixel in our map. Okay, again, this report can give you the information for each subbasin, even in terms of soil, of bands, and also for each channel. So it's quite very detailed that you know what's happening in each of these points, in each of these unit. So as I said before, if you want to change the threshold and the selection of these HRUs, we will have to go back to the create HRUs and read the previous run to make appear the new HRU selection. that we can choose. Okay, what has been created here in the map? One of the layers that have been added now is this, as I told you before, is this actual HRUs, starting from the full HRUs. That is created just only when we have selected the tick on the full HRU file, as we did. Otherwise, it's not created. So this contain all the information. If I open the attribute table of this file, you see for each, for example, if I select this first one, that is this one here in the map, we can see the description of the property for this part. We know which is the landscape type, if it's upslope or a floodplain. We know which is the land use, that is in this case forest. We know which is the soil, which is the soil band, in this case between 0 and 10%. The area. Then we know the percentage respect to the subbasin, the percentage respect to all the landscape of the same type. There is a number given to this HRUs. This is name 5. And then there is another ID number that come actually from the previous channel definition. Then, as I told you before, there are these holes inside the watershed, but in fact, all the HRUs that are not shown here, they are proportionally given to some other areas here, to the closest area here, or let's say the one with some same characteristics. So that at the end, the total area of the watershed or of the subbasin will be the same, even if without these parts here, it will be distributed to all the others around. And this comes from the elimination of HRUs that we have done in the last process. So then, okay, I already told you about the shape file. The shape file with attribute table. The only thing is that, as you see here in the column of HRUs, there can be more than one values for some of the features, and this is because it's impossible to show in this shape file the splitting by arbitrary amount in the original potential HRUs, because actually we have done the splitting. In this case, was when we have selected agriculture to become both or either corn or teff. And as you see here from the land use, is still written agriculture. But these two numbers means that one is of one type and one of the other. It's just that it's not updated in this table, but the model will consider it for the simulation. So it's just a matter of visualization or a presentation of the results. Okay, some other channels, some other shapefile that have been created is this channel reaches. Let me remove the selections. Channel reaches. I remove also the HR use. Okay, this channel reaches is formed from the channel shapefile, but considers also the delineation that we decided, for example, when we did some merge of the channels. That if you remember, we selected to not consider the channels that are less than 2% of the total one, and they have been added to the other one. So actually, what you see from the configuration is the same. It's just that in these in their characteristics, they have been merged, some of them. And another shapefile that is the one that you see here, all these points. This shows point sources. Is in the shapefile. Is this one, the shapefile point sources and reservoirs. They are automatically added to each channel. If we see the channel, okay, they have been added to some particular point, specifically at the beginning of the channels. Let's say at the input part of the channel and in the junctions between different channels. They are added there because it is more convenient like this. If in the next step in the SWAT editor, we add some data that we want to add at this point. So we could add information that we have at this point, and it has been created, this file, just at this point of the watershed configuration. Okay, after this step, as you see in the main window, it's written as done, also this creation HR use, and we will be ready for the step 3. That is about the edit of inputs and the run of SWAT Plus. And before starting this, please tell me if you have any question about this part that I explained today, or about some dubs, or everything. So, okay, next step. For the next step, we will move out of the QGIS environment, and we will move to the other component, that is the SWAT editor. For this, as I told you before, that's important to disable the antivirus. Otherwise, it will not work. And to open the SWAT editor, we can do it in in two different ways. We can both click on this step 3, edit input and run a SWAT plus. So we can click on it. Okay, if I click on it, okay, let me put it here. Okay, just one thing before, because before starting, this is the part of the simulation of the model where we put as an input the precipitation. So at this point, we should have prepared some general weather generator information. And for this case of this rabbit, for this example of today, the folder that we have in the directory already includes such data. So it's not needed a preparation for the precipitation, because we have already the data, and we will put them as an input here. More than the same thing for the observed weather data. I mean, this weather generation and observed data are two steps that we will be doing. We will see now why do they differ, but they are basically two tables that were already prepared. So after starting the editor, we need to click on Start to import the project and the reference databases. So the project display name, we keep the one that is proposed to us, demo 1 in our case. Here we could write a brief description. We don't have to tick this option here down, and we go to Start. At this point, this SWAT editor is importing our data from QGIS environment, from QSWAT, to this editor here. What we can see that there are here the main result of the QSWAT that we have done before. There is the indication of the total area of our watershed, simulation period that we can change, we will see later. Created with, okay, in this case, SWAT plus editor here, and QSWAT, that is the one in QGIS. Okay, last saved, and then we have some main information about the totals of the object, the 9 subbasins. This is the 657 HRUs. That was the total number, not the one that has been lowered because later before we have done this redistribution of areas, so our actual HRUs will be less than this, but this was the initial number. Again, this is the number of channels, aquifers, in case we have reservoirs, and the routing unit, and that will be the channels in our case, channels and reaches. The landscape unit, and these point sources, that was the last file that was created, as we saw. We have also a graph about the land distribution, so we can see the distribution of land use. That is, for this case, in example, it was 1.8% of forest, so a small part is of forest. A 7.6% is of pasture, and the remaining is 45.3% of teff and 45.3% of corn. Exactly the same percentage, because we have divided the agriculture into identical part. Okay, At this point, we are asked to there should be the option to get started that I don't see here. Let me see if it's down here. Okay. It was not written, but you should either, or you should have this, but we will do in the same way. There is this, I'll show you in the presentation, there should be this get started option here that leads you to the next part, but otherwise we can go anyway to the next phase that will be, I will show you how we can reach it. Okay. Okay, 1 second, let me open. Okay, the first part to work with is this in this, sorry, let me, okay, here in this pencil that you see on the top left, that is edit SWAT plus inputs. That is the one where we have to set at first our weather. Other weather, so for the input of the precipitation record. So how we do this? There is this, there should be a button that is called, or it can be add the weather generator now, or in my case, since I don't have it, there is this create record. No, sorry, it's not the created record, is the import data. Is the import data, sorry. Okay, and here we have the same page, import weather generator data. So from here we have to select your data format. There are these 3 options: database, or 2 CSV files, that is that has a separate file for station and monthly values, and or 1 CSV file. In our case, we have 2 CSV files for the rainfall data. Maybe I'll show you before how these files are, so you see the files that we need to put as an input here. We can get them from the folder of the exercise. If you go to the exercise, it was in the SWAT folder, SWAT plus. In this case, let me see, where is it? Okay, example dataset, Robit. It's one of the CSV file. In our case, is this one, the last two ones here are the one that we'll put at this point of the editor. So if we open, for example, this the last one, the Robit stat. This file gives just the information about the stations that we have. So basic information about the station will be an ID, a name will be given, and then important, the latitude, longitude of the of our point of the rainfall, the elevation, and how many are the numbers of years of rainfall that we have. So this is the first file, the simple one with just the list. In case we have more station, we will have to add other station with other name and so on with the latitude, longitude, elevation, and name of the numbers of years you have. In this case, we have just one. I'll close it, don't save. And the other file that will actually be okay, this one will have the information about temperature, temperature mean, temperature max, precipitation average, some other information for precipitation. And this is monthly data. As you see, there are 12 rows, and for each of them we have some monthly precipitation. So precipitation days, hours of precipitation, I mean, some information about the precipitation. What we want to see is from here, from the editor, how to upload these files. So to do this, in case we have these two CSV files, that means separate file for stations and monthly values as we are. We click on this. Here are the specification of which the column, which values and names the columns need to have. So as we saw before, the name, latitude, longitude, elevation, rain years for the station file, and for the monthly values of file, all of this month, temperature, maximum, minimum, again, precipitation, average, and so on, precipitation days and other data. So after this, we have to select the folder with the station file. Okay, I'll go to the Robit folder, and it was the last one. wgen Robit st8 stat stations CSV. Open. Okay, we have uploaded this one. The second one again is the monthly values CSV file. So we will have to select it. That is this here, Robit mount.csv. So we open it. And I have to check the box here because I have to state that I am using observed data weather because it's a data that we have. After this, I click on import data. Okay. You see that the weather data generator is imported, and you will see this single row of our station, since we have one station, and you see this is like what was written in the Excel file with the name, latitude, longitude, elevation, and raining years. So with the weather generator setup, we select now this weather station, because at this point we have to import this kind of data, these weather stations, and I'll show you how is it done, because you see from here that we have some different values that have to be provided. Precipitation, temperature, solar radiation, relative humidity, wind speed, potential evapotranspiration, atmosphere deposition, and latitude, longitude. And this file, I can open it from this, again, import data. Okay, I see that the observed data that we have, I know that is in this format called here SWAT 2012 format. That's the one of our case. So we selected, here there are some indication about, it says each measurement provided must have a file named psp.txt, RH, this radiation.txt, solar, temperature, wind, and so on. But we have already the file created, so we will work with what we have already. I have to select here the files directory. No, actually, this will be, sorry, file directory. I will have to select my directory, the file where there are this weather information, this weather data. It is in, for this case, Robit, climate Robit here. I select the folder. Okay, because actually you couldn't see what's inside, but if we go to the folder, to the directory, climate Robit, we have all of these files, all these txt files for the different information for, let's open, for example, the precipitation, this one. Okay, this is actually just, it was for the, is the reference between the two files that we had before in the weather generator, but because the other one already had the precipitation inside. Okay, but I had to select it from the editor here, and the next directory to select here is the where we want the file to be saved, but we keep the what is already compiled here in the scenarios folder of our model. There is a txt in and out. I keep it what's here, and I do click import data. Okay, now we see that also this weather data will appear and showing our single station with data for precipitation. Let me, okay, now we can see the precipitation that inside this file. We couldn't see actually from the txt, but only when is uploaded in the weather generator. So for this we can see the type of data we have. We have data actually starting from 1990 until, let me see, until 2013. And this kind of data are actually daily data. As you see from this column here, we have data, for example, this 2012, it was from 1 to 366 in this case, and the same for 2013, from 1 to 365. That is the number of days in that year. Here in this column on the right, we have the precipitation in a millimeter. So that's the data we have, and it will be the same for the other information like temperature. I can see this file here, where we have here actually this is the maximum temperature on this column, and this is the minimum temperature. on the right for all the same period from 1990 to 2013. Okay, the same also for humidity, wind speed. In this case, we don't have a potential evapotranspiration in this file or atmosphere deposition, but the model will run anyway with this data. Then the other step to set up here in the model, next to this climate information, is the simulation period. That is this triangle symbol here on the left for the run of SWAT. That opens the simulation setting page. For this, the input files can be left as a default. This one, choose where to write your input files. We have chosen the same folder as before, but we leave it. And then there is this set your simulation period. We say that we have a rainfall that is in a daily data for from the beginning of 1990 to the end of 2013. But for this case, to keep down the time needed for the run of the simulation, to import all the output data, we will restrict the period between 1990 to 2000. So we will change. Actually, okay, the starting day of simulation, we will keep this one. 1st of January 1990, and for the ending date of simulation, we will use this calendar to set up. Also, we can write it by end 2000, 1st of January. 1st of January 2000. Okay. That is what we like. Okay, we have set this simulation period. And there is this option about the choose output to print. In this option, the first thing to set is the warm-up period. That is the period that will be considered for the simulation, but as a starting for the result, you will see just the outputs that will come after this warm-up period. It will be used just for the warm-up of the model. We decided to select 3 as year of warm-up period. Here in this point where we see all of these description of the different components, this list of different components, these are the outputs that we want that we need to select in order to have to see the result after the simulation. Specifically, we can visualize a variety of different outputs, and we have to select the time step for each of them that we want to see. So by default is given the yearly output for all of them, and also the average for all of them, both either for all the model components, channel, aquifer, reservoir. Okay, these are quite the same. Channel, aquifer, reservoir, point source, basin, landscape unit, response unit, regarding different things, nutrient balance, water balance, the plant weather, losses, the salt, some constituents. What we want to add is for sure respect to yearly and average, the monthly data for all of them. To select all, we can click on this monthly on the top, and for all the components, it will be selected. But what we want also is for the channel here to have also the daily time step, because it will be needed to the calculation of some environmental flow that we will see later in the next step. What will be? It's some kind of analysis that will be done only if we have this daily option of channels setted. We decided not to include all of these daily output, that just because for this purpose it will take some time to write all the records for this, and for the exercise we can see that the results just for monthly, yearly, and average data for the others. So if I scroll down at the end of the page, there is this run SWAT plus, where we have to tick to write input files. That has been already ticked, so we keep it. The same run SWAT plus rev 61.0.1, we keep it. We don't need, for this case, they use debug version. And we want to keep the analyze output for visualization. Now we are ready to save the settings and run the selected options and run the model. So I click on this. Okay, it can take some time to executing this simulation. Not a lot actually. It's doing year by year this calculation. We'll wait a few seconds. Okay, now it's reading the weather files. Here it also depends on your laptop of how much time it will take to run this simulation, and of course of the selected time step. If we had selected a daily time step for all the parameters, it would have taken so much time.
Yes, Giacomo, if I can ask a question in this issue.
Yes, sure.
So our target is to calculate the sediment, is it, for using this SWAT? I don't know if it is included in this tutorial or not. It is. It is because please proceed.
Yeah, sediment calculation is just actually a part of the model, because all this part about hydrological analysis is needed to for the simulation of the model. The final result, I mean, the sediment is just is one of the result of this simulation. Is one of the main output that that we can actually see. But yeah, the base of this model is to be an hydrological model, so it has to be taking into account all of these steps.
Yes, because when we see the gradients, it is mentioned salt or all these gradients, but there is no any mention for sediment. I don't know. Anyhow, let us wait until the end of the output.
Yeah, at the end there will be some output. There will be some list of some parameters that they were not written there in the list. But there will be, for example, an output that is called sedimentation yield in different years. There will be a lot actually of output, and also for some for sedimentation one. Yeah.
Okay, perfect.
Later we will see some. Yeah.
Thank you.
Okay, at this point the model has finished to run. All selected tasks have been completed. It says run SWAT check. We have the possibility to open a toolbox, save a scenario, or open the result directory. Okay, in this case we can go back to the editor. We come here, that we see the okay, here also we see that the simulation period has gone to the correct one, because before, until we hadn't go to run, we still had the 2013 selected. So now we all have the information we wanted, and we actually can close this SWAT editor, or exit from here, exit SWAT editor. And if we see from the main window of QSWAT, we have our new step 4 that is the visualization that can be seen here, and that we can play with. So we have completed also the third step, and we are ready for the next one. And I think that at this point we can stop here for now, and continue later. And in the meantime, do you have any question or something to ask for anything? Please tell me in case.
Yes, at this stage we have to save the file, or it is automatically saved?
Okay, yes, actually it's better to save the file. I also always forgot to do it from the save project of QGIS. It's better to save it sometime. I did just now, but yeah, it's better if you do it every step that you take is better to save the file. Yeah, from here. The editor does it automatically, but you have to do it from the QGIS. So we press OK. This is fine. Okay, and now we have the model is saved. So if you don't have any more question, I think we can.
There is a question in the there is a question written. Yeah.
Yes, I need to know more about preparing weather data for SWAT model. Okay. Okay, I understand. Weather data for the SWAT model. If you have in it an Excel format, actually the format that need to be put inside the SWAT model, I would say it's not very easy to set up. Okay, let me open the SWAT editor. It requires some format. Okay, let me go to. Okay, in this case, if I go, for example, import data, actually it will be asked to use this kind of data for the precipitation. So that is a SWAT database or a SWAT plus. So actually, for this case, I would like to say the best thing is if you don't have a data like in this format, in this particular format, that actually personally I don't manage it in like a very expert way. I would use also, because there is another interesting option to use a data of rainfall that is already inside the SWAT, because there is also this possibility inside the weather generation. There is already a database. Instead of using this CSV file, you can use a database that is already in the SWAT model that has some information of rainfall for many points, for many different points. But actually, this would be my suggestion to use this kind of data if you don't have a data that is prepared in a SWAT file format. So yeah, that's my suggestion. Okay, I see the question about QGIS that I stopped responding after a second step. Okay, that can happen actually. It depends on your laptop, and if it's maybe it can be heavy for some laptop, some kind of calculation. But that's a matter of QGIS. For this we would need to save many times the project, and then if it stops responding, we will need to try to close it and try to open it again. That's a thing that actually happens many times using QGIS. Okay, I see a screenshot here. Can you please tell me what is this screenshot about, Emmanuel?
I think the SWAT is not run well, I think. Otherwise, because it should be, there is a step 4, which is not included here.
Yeah, that's because the step 4 appears only when the
SWAT properly
this editor,
run.
the editor has run. So for some reason it hasn't doesn't run properly. Maybe also because I don't know if it takes some time or just but just looking from from the screenshot, yes, it is difficult to know what was the problem. I would have to know if you run maybe the SWAT editor before. Yeah.
Yes, hello.
Hello.
Yeah, my question is that after the lunch,
Yes.
you can just go back to the step number 3, just to revise it. This is where I just reached it, but I don't have the question, but I need to revise the step number 3, the edit, the input. Yeah. So after the lunch, it's just my note, but I just take the screenshot to let you know what step I reach to. Yeah, thank you.
Sorry, I don't get. Did you run the SWAT editor?
No, not yet. Not yet. I just reached to this. Yeah, not yet. Yeah.
Okay. Yeah, the step 4 actually.
Before after the lunch, I need you to go back. Yes, yeah, just to revise the step number 3, the input, the edit input. Yeah, just a revise the steps.
Okay. Yeah. So you will have to. Okay, let me open now.
Is it he wants to revise the last step for editing SWAT, but let us do it after the break.
After the break, yeah.
Yes, yes.
Yeah, sure. Okay, Ben. So, okay, see you after the break of 1 hour, and yeah, we will continue about our discussion. Yeah, thank you.